Okay, now moving on to the next presentation, we have Tang from Silver Paste Supplier Fusion. Ocean is a tech director of heterojunction division at Fusion, and he's going to talk on progress in development of Fusion HJT paste. Ocean?
Hello, everyone. Can you hear me?
Yes.
The picture is okay?
Yes, but we cannot see you properly. Maybe it's a good idea to switch, disable the.
Yeah. So let's start.
Yeah, please share the screen and.
So hello, everyone. I'm Ocean from the China Paste Maker Fusion. So today I will share about the Fusion, the HJT paste progress. So firstly, I want to share you the current situation. What's the current problems HJT the paste cost? As you know now that we are meeting the biggest the problem is the HJT the cost is very higher than the TOPCon and the PERC. So I will show you the current situation and our plan how to achieve the cost down. So first page I will show you now the average cost for the HJT and the TOPCon and the PERC. So you can see the current situation is now HJT the SMBB and the zero paste and the zero BB zero paste. The cost also is much higher than the TOPCon and the PERC. And but from the current the technical speed we can achieve the average the similar cost the paste cost because we're using the cost done by the zero paste and the zero busbar and the zero busbar and the combined by the zero copper paste. So after half the year, so we can achieve the same cost the paste same paste cost compared to TOPCon, but still higher than the PERC because the zero copper paste the price is much lower than the zero. So we can see the next Q2. So the zero copper paste the cost is much lower than the TOPCon. And the second page, I will explain why the HJT paste the cost is so high and the efficiency and the correction time not enough. First is why the cost. So now the HJT paste the first consumption is much higher than TOPCon, and the second because the price is very high than the TOPCon and the PERC paste. Because the price is from the second of two items. First is processing charge fee of the zero powered. As you know, the TOPCon, the paste and the PERC paste, every month we were using the several hundred ton, but the HJT paste because the capacity is still not enough. So the usage is around is less than the 100 tons. So the charge fee is very high. And the second is the zero containment. You know, the TOPCon paste and the PERC paste, the zero containment is less than the 90%, but the HJT paste, the zero containment is much higher. It's around the 2 or 3% higher than the HJT paste. So that's why the HJT paste, the cost is much higher than the TOPCon. And the second, because the printing speed also is lower than the TOPCon and the PERC. So the capacity is not enough compared with the TOPCon. And the second one is current time, because the TOPCon paste and the PERC paste using the firing process. So the firing time is less than the 2 minutes. But for HJT, we're using the low temperature curing time. So the time is much lower than the TOPCon. That means that the process time also is means the cost. And the third one is the efficiency. Actually, for the HJT paste, the now that the code type language is around the 30 to 40 micron, but for TOPCon, we can achieve the 25 micron. So that means the ISC will be lost because of the paste. And the second is the conductivities. You know, HJT paste now we using their different cell power from the TOPCons. That means that the capacity is also is very higher than the TOPCons. So the efficiency lost by the paste also is higher than the TOPCon. So that means we are now meeting the 3 weak points for HJT paste. I know we know the problems, but how to do and how to custom. So I think we have 3 ways. First is the pattern optimization. For example, for finger, we can use a nano and a nano finger width. And the second is busbar. We can use the different pattern, the busbar. As you know, now the more and more the companies using their zero busbar, so we can cost down the busbar paste. And the second using the raw material custom. So firstly, we were using the more cheaper the cell power. That means we can price down. And the second, we can use the copper and other materials to replace the cell power. And the third one, we can use the low contained paste. That means we can use for example, we can use the backside finger, and the busbar paste, we can use the less silver content. And the third one, we have to increase the production capacity to custom the total price of the one factories. First, we can increase of the speed by optimize of the paste the performance. And the second, we can develop different short time the current time the paste to the speed up the capacity. So in our schedule, we can see from the current situation, you can see most of the customers using the SMB and the finger language is around 18. And the backside now more and more the companies using the backside the silver AG copper paste. And one quarter later, we can see if we still using the SMBB and the 2 micron nano width, and we can use a bifacial AG copper paste, so we can cost down around 30%. And next Q2, if we started to mass production zero busbar and use a nano finger and bifacial AG copper paste, so we can achieve the same or cheaper the paste cost compared with TOPCon. As you know, we know the time and we will know the problems and the fusion. Now we are developing the different paste for the HJT cells. So firstly, we using the finger paste. We have 2 versions. First is pure silver paste. Second is silver copper paste. And the busbar, we will have the 2 kinds of the paste. First is pure paste. And the second, we using the silver team paste. So you can see for the finger paste, we have the 2 kinds of the version. First is zero busbar, and the second is SMBB finger. And for the busbar paste, we have the two kinds of, as I mentioned. So we can also not only the finger paste, but also the busbar paste. We can use the low silver content paste for the cost down. And for the busbar paste, how to cost down. So you know that 2 years ago, the busbar paste, the silver content also is very high and is similar with the finger paste. But now, after 2 years, so now we are using the 1% low silver content busbar paste, and for the this year Q2, so we can use the low. We add other paste around the 20 or on the 100 or on the 80% the silver content paste, and next Q2, so we will using the 70% silver content paste. That means the busbar also we can the cost down by the less silver paste. And for the finger paste, so now we can compare with the TOPCon. As I checked the data last year, the TOPCon, for example, the TOPCon, the masking opening is around the 60%, and the paste the consumption is around the 15%. And this year, because the TOPCon, the cost down the speed is slowed down, so the HJT paste, so we can achieve the similar level with the last year the TOPCon, and the next Q2, so we can see the same several consumptions. And the last one, I will introduce the everybody want to know the HJT, the silver copper paste. First, why we using the copper, not other paste, not other metals. You can see first is the conductivity is very close to the silver, and but the price is one is much cheaper than the silver. So that's why we use the copper. This page, I will show you the different copper content, the cost down. The baseline is the pure silver paste. As now in China, most of the company using the 50% silver content paste. So we can cost down around 25 to 30%. And if we keeping decreasing the silver contents down to the 30%, we can achieve the around the half price of the silver paste. And you know, we were also developing the other materials. For example, long material. For example, the silicon. We can use in order the silver coated silicon or the liquor, other materials. But the problem is the RC is very high. The efficiency is lower than the silver copper paste. So the last one, I will show you the weekend the edge coated copper paste. So we can see if we use only back side using the silver copper paste, the efficiency almost similar with the pure silver paste. But if we using the bifacial, the efficiency will decrease 0.01% because the fear factor much low. And we were also developing different mask opening paste. If we from the current 20% to the 60%, the laydown will cost down around 20%. So let me summary. First, the HJT paste shows the high cost and the low process time and the low contribution to the efficiency. But we can cost down and buy the pattern and the cheaper raw material and higher capacity. So we can cost down by the busbar and the finger AG coupled paste and achieve the same cost with TOPCon. We can achieve, I can see, so next Q2, we can using the 60 micron the screen mask and achieve the 13 milligram per watt, the AG copper paste. Okay, that's all.
Okay, thank you very much, Ocean. I think this is very informative. Mostly you answered all my questions what I had during the presentation at some point of your presentation. So thank you very much for your presentation.
Okay, thank you, yeah.